So I'm going to call these sections of videos Quantum Mind. What they're going to discuss are science, the universe, astronomy, us, the physics of us, the science of us, the earth, geology, how things play together, work together, how that affects us all together. It all plays together. There's balance and connectivity. So here we go. And I'm going all science here because I really do want to get to the point of discussion of our universe, of things like this supermassive black hole that scientists are now saying exists in our own galaxy. As far as I knew, going near a black hole would tear you in half. Yeah, I'm not going to be the one testing that theory. But this also affects us, our lives here on Earth, the science here, and personally, our own magic, our own internal natural abilities. When I say magic, I'm not talking about black magic. I'm talking about what we were born with, the science of us. First of all, getting into matter. When you were in school, how many forms of matter did they tell you exist? Let me guess, 3. Liquid, gas, solid. Yeah, those are the 3 primary, but they forgot a couple, didn't they? Okay, some of the other forms of matter have become more known or more discussed, and some of them are easily reproduced here and exist here. Others we've seen out there in the universe and have somewhat been reproduced, but still experimental, and that's growing. That's a growing world. So plasma is one. What happens when temperatures become extreme and the electrons get excited and separate from the nucleus, then they can interact with other nuclei nearby. One example of this is fire. There are more than one forms of plasma out there, such as ionized plasma and quark-gluon plasma. That plasma is what you would see like in the creation of the universe. That's the highest energy matter, where all the forces come together. At that point, that's extremely hard to try and reproduce that, obviously. So in particle accelerator experiments that have somewhat worked on trying to produce those results, they've noticed that the plasma behaves like a perfect liquid. In other words, it's moving like in a very specific pattern, like a flock of birds might do. So when you get into the extreme low temperatures, we're talking somewhere near 0 Kelvin, which is basically absolute zero, then you're going to find the condensates, that type of matter. There are a couple different kinds of condensates. One is the Bose-Einstein condensate, and that involves bosons that end up in an almost equal quantum state. Okay, then you have the fermionic condensates, and those are a little bit more difficult to produce. The fermionic particles can't be in the same quantum state, and they operate via the Pauli exclusion principle. So in order to get into that superliquid state where they're not dissipating energy but they're still flowing, it's a little more complicated. What happens is the electrons have to pair up into Cooper pairs, and when they do that, then they can have that liquidity without dissipation, as long as there aren't collision events that cause them to break apart. Okay, there's a type of matter that we see in the cores of massive stars, and that type of matter is degenerate matter, and that's at super high pressure. In these cores, the pressure allows the electrons and the protons to bind together into neutron cores. And in that case, the electrons can be shared between atoms. Degenerate matter is actually not thermal, but quantum. Okay, I used the terminology in here. I said superfluid. What does that mean? There's superfluids and supersolids, and what those are types of matter that can flow, move, they can have velocity without dissipating energy. And while I'm at it, I'll just go ahead and bring up supercritical liquids. Those are formed at extreme high pressures, and what identifies them is actually the lack of distinction between liquid and gas. They're kind of neither, but both. Do you ever wonder what's in the sun's core? Well, similar thing to what's in Jupiter, but the sun has a lot of fusion going on in the core, which is where we get a lot of our energy from. There's a hydrogen process going on, and in order to find something similar to that matter, it takes extreme measures. Our Earth's atmospheric pressure would need to be 3 million times stronger to reproduce those results. So it's been very difficult. Scientists have come close by squeezing hydrogen particles between diamonds. Interesting, right? And what they found is partially atomic and partially metallic results. So there you have it. When we talk quantum, there are things in the universe that have this memory, this pull to one another, that find a way to be together, defying what we know about velocity, about time, about space. So they wind up making this quantum leap. It's funny how science sometimes mirrors an understanding of us, of people.